All right. So how would we describe the end behavior here? Let's just do one error at a time.
You start from left to right, right?
You can do either one. Doesn't matter which one you go. Which one do you want to do? As x approaches which way? Negative infinity. What's happening to our y values? Y approaches negative infinity. My left arrow is going down. That's what this one is talking about. As x approaches negative infinity means as we go further and further left, my y's go farther and farther down. So for our other one, as x approaches positive infinity, what happens to our y's? They're positive. They're going up. This side is going up. Bless you. Okay, so we can read the end behavior from a graph. We can build our end behavior from an equation. We looked at that yesterday. And we're going to practice today looking at some bigger equations, and then we're going to look at end behavior like this on a graph and see what that tells us about the equation. So we're going to go the other direction. Our second question up here, this is old school, is how many roots does this function have? What are, there are 4 words that mean the same thing as roots. Do you remember what any of those other words are? Bless you. Roots are also called our solutions, our zeros, or our x-intercepts. Those words all mean the same thing. I have a tendency to say a lot of them together. So the zeros, the solutions, the roots, the x-intercepts. How many of those does this graph have?
3.
You see it crossing 3 times?
1.
It's just 1. Right here is the only place it crosses. So this has 1 root. If it had more than 1 root, it would be something that like wiggle, squiggle, wiggle. That guy has 3 roots, the yellow one. We could do lots of roots. But this guy just has 1. It's all about the number of times it crosses that x-axis. Okay? Questions on the bell work? Cool. Pretty job, not super intense. All right, so we are going to be looking at very similar things like we did yesterday, but instead of it having just one little piece in an equation, it's going to be bigger equations. So yesterday we worked with things called monomials. Today we're going to look at polynomials. So monomials had one term, one thing, that one chunk, our ax to the n. Polynomials are going to have many chunks like that. Each of those chunks can still be ax to the n. It's just we're going to have more than one chunk. So we're going to look at something called polynomials in one variable. We are only looking at one variable. So very, very important that we're looking at one variable. That means we're only going to have x's, only going to have r, only going to have t, only going to have v, whatever our variable is just one in all the things. It can be a y equals x squared plus 2x plus 7. Like, that's totally fine. But it's not going to be like 3xy, 4xy squared. It's not going to have more than one letter in each of the terms. So our first piece that we're going to look at here is something called standard form, and it's going to be really helpful when we're looking at really, really long polynomials to be able to put something in standard form. And what that means is we're going to put the terms, so standard form is putting the terms in order from largest to smallest exponent. Exponent is what we're looking for. So, for example, something like 7 plus x squared is not in standard form, but x squared plus 7 is. Our biggest exponent's in the front, and they get smaller from there. So this has an exponent at the end, not cool. This one's biggest, and then we go smaller from here. So this is not standard form, this one is. Hi, Kennedy. Hey, they got the stations working. There's one of the verses about it. Yay. All right. So the next thing we're going to talk about is the degree of a polynomial. So we talked about our degrees yesterday for our little individual pieces, but the degree of a polynomial is going to be the largest degree, or the biggest degree, of any one term. And I promise I will show you what this means here in just a second. Any one term. And then our leading coefficient of the polynomial, so again, we had degree yesterday, we have our leading coefficient. It's going to be the number in front of that biggest degree. The number in front of the term with the highest degree. That is the most writing I did today. Most right after this, it's equations. So we're going to look at some equations. We're going to figure out what our leading coefficient is, what our degree is. We're going to use that to talk about some end behavior stuff. But we are only working with polynomials in one variable. So that's an important piece here. We're not doing more than one variable inside it. Okay. So we're going to start by looking at some polynomials. We're going to figure out our degree. We're going to figure out our leading coefficient. We're going to put things in standard form if we can. Okay, cool. All right. So we're going to look and try and find our degree. We're going to look at this first one over here. When I say that our degree is the largest degree of each individual term, what I mean is we could find the degree of this guy, we could find the degree of this guy, we could find the degree of this guy, we could find the degree of this guy. I want the biggest one. So, thinking back yesterday, what is the degree of 2x to the fourth? 4. Our degree is our power. So if we look at each individual term, this guy has a degree. Whoa, that is not a pen. That was a highlighter. This guy has a degree of 4. You don't necessarily have to write this out for each term, but I'm just going to do it so we can see what's happening. If I look at just that guy, the 3x cubed. Did not bring that. Just this 3x cubed. What's its degree? 3. Actually, I'm going to change my mind. I'm going to do that. So our degree here is 3. What's our degree on this term? 2. And what's our degree on this one? What exponent does it have? 1. Good. There we go. So, what is the biggest degree that we have here? 4. So this is our most important term. That guy's important. This is our biggest degree of any individual term. So the degree of our polynomial is that biggest degree. So the degree for this whole thing is 4. So 2x to the 4th has a degree of 4, and 2x to the 4th minus 3x cubed minus 4x squared minus 5x has a degree of 4. It's the biggest exponent. Since this is the term that has the biggest exponent, what might our leading coefficient be? What coefficient is with the term that has the highest degree? 2. So the leading coefficient of the polynomial is 2. So I know we have a degree of 4 and a leading coefficient of 2. So is this polynomial even or is it odd? Even. Our degree is even. Is this positive or negative?
Positive.
Positive. So can I see what's happening to those arrows even though I know nothing else about this polynomial? So let's write our end behaviors. So if we know it's even and positive, that tells me that as x approaches our positive infinity, so as we go to the right, it's going to match the sign of our leading coefficient. Our y's would approach positive infinity. And since it's even, are they opposite or do they match? They match. So as x approaches negative infinity, what does our y approach? Positive infinity. Okay? And since we're here, let's double check and see if it's in standard form. Our standard form means it's in order from biggest to smallest exponent. So my biggest exponent, we've got it right in the front. Excellent. Then 4, 3, 2, 1. It's in standard form. That's what it looks like when it's standard form. So this is everything, everything, everything for the whole day for that one question. Okay? Questions on that one, because it's the first one we did. Checking in, because I know we're sleepy. Okay, we're going to do the same thing on the next one. We're going to find the degrees, and we're going to figure out which one's biggest. The degree is the biggest exponent on the letter. So what might the degree be for something like 2? Remember we had 1 over here when we had 5x. So does this have a letter in it at all? So what's the exponent on that letter? If it doesn't exist, so 2 has a degree of 0. If it doesn't have a letter, it doesn't really have a degree. Degree of 0. What does this term have as a degree? 3. So this one has a degree of 3. I don't know what that was. So what is the biggest degree in this polynomial? 3. So this guy is in charge. So the degree of the polynomial is 3. Just moving that over just a smidge. What is our leading coefficient then? Careful, careful, careful.
Oh, negative.
-7. The sign goes with it. -7. So Is this even or odd? It is odd. Our degree tells us that part. Is this positive or negative?
Negative.
Negative. That's why that sign is so important. It has to stay with it. This is a negative leading coefficient. So we can tell our end behavior here now. It's odd and it's negative. That means I know as it goes to the right, it's going to be negative. That's what that tells us. So as x goes to the right and approaches our positive infinity, we know that our y is going to approach what?
Negative.
Gorgeousness. Yes, negative infinity. And since it's an odd degreed function, what does that tell us about what happens when x goes to negative infinity? Where does our y go then? Yes, because odd degrees have opposite arrows. Odds are opposite. So this is going to go up to positive infinity. Okay. Is this in standard form up here? Do I have my biggest exponent in the front? My biggest exponent is the very last piece here. I want to go from biggest to smallest. Biggest to smallest. So what is my biggest degreed term? What was my highest degree?
3.
The 3. So we want this guy to be our line leader. He's in front. He should be in charge. So if we were writing this in standard form, I'm going to put it down at the very, very bottom. I know it's going to be super low for some people. We want that negative 7x cubed in the front. But if I just take him and pull him to the front, what's going to be between the 7x cubed and the 2? Plus. It's a positive 2. So when we're putting things in standard form, if there's subtraction signs there, it's super duper important that it is a minus 7x cubed minus 7x cubed. It's not going to be 7x cubed minus 2. That would be the most common mistake I have, is that we just flop the two terms and keep the minus sign in between. And we will practice more with the standard form stuff here on the next page. We're going to practice that a couple of times. Questions on that one? Okay. So we got one more piece over here. We've got 4x squared y minus 5. What do we notice about that? There's two variables. Do we know how to find our degree or anything with two variables? So in terms of the things we can do, this is not a polynomial in one variable. This is not what we're working with here. This is not a polynomial in one variable. So it's not something we're going to be able to find end behavior for. We're not going to put it in standard form. We are not going to find our leading coefficient or our degree. I'm not saying it's impossible. There are ways to do it. It's just not going to be something we do. Okay, so we are not working with anything that has two letters like this. This is what I mean when I say two letters in one term. We had 4x squared y. That's one chunk there. Icky. Didn't even touch it. Grumpy screen. Okay, so if we have something like this, where I have x squared and y, or x and y multiplied together like this, we can't do this. It's not a thing that we're doing. Okay, so that's not solvable. It'll be like a no solution kind of situation for us. Okay? So that's what we mean by polynomial in one variable versus a polynomial in more than one variable. Questions on this page? Cool. We're going to practice all this stuff again. We're going to put them into standard form, find our degree, find our leading coefficient, and state our end behaviors. So exactly what we did on the previous part. It's just there's only 2 on this page. Definitely meant to print out those graphs, but I totally forgot. Okay. So let's look at this left one. And we can do it exactly the way we did on the previous page. We're going to figure out what is our degree, what is our leading coefficient. We're going to get it in standard form. And you can do them in any order that you want. I don't care if you find your degree first, your leading coefficient first. Okay, I don't think you can find your leading coefficient first. So degree first, or if you put it in standard form first. Doesn't matter. I'm going to go ahead and let's do our standard form. So we're going to start by putting it in order from biggest to smallest exponent. So what is my biggest exponent? Where's our biggest exponent on that left one? Over here. What's our biggest exponent? 5. This guy. So this needs to be in the front. So we're going to have our 2x to the 5th. It's our biggest exponent. What is my next biggest exponent? The 3. So we need to take this piece. But we also notice this guy is being subtracted. So we notice that minus 7x cubed. What's my next biggest exponent?
2.
The 2. So that one goes next. It's a positive 3x squared, so we're going to put our plus 3x squared. Next biggest, gorgeousness, our plus 2x. And one more piece, the minus 3. So this is in standard form. It genuinely does not matter if you do your standard form first or finding your degree first. The only benefit of doing standard form first is if we've done our standard form correctly, this guy should be your boss term. This one's the one in charge. This is going to be our leading coefficient and our term with the highest degree. So that'll be the degree of our polynomial. You can do degrees of each of the terms and find your biggest that way, or we can put it in standard form and say this guy's the one in charge. This is our boss piece. So what is the degree of this polynomial? What is the degree of that pink term? What's our degree? 5. And what's our leading coefficient? 2. So by putting it in standard form, it just puts that term that's in charge right in the front. So sometimes it's helpful to do that. Sometimes it's easier to do it the other way around. It genuinely is up to how your brain likes to process things. It doesn't matter what order you do them in. So now we know our degree and our leading coefficient. So is this thing going to be even or is it odd? Is this positive or negative? Positive. So I know it's odd and it's positive. We can find our end behavior. So we know as x approaches positive infinity, as x goes to the right and gets bigger and bigger and bigger, my y's are going to match our leading coefficient. So my y's are going to approach what? I was like, if we're looking at our right arrow, it should always match our leading coefficient here. So it's going to go up to positive infinity. So our positive x is always going to match whatever this piece is here. So if it's positive x, matches our leading coefficient, positive. We're looking at opposites here, or odds. So they go opposite directions. So my y is going to approach what? Odd means opposite. So we're going to approach our negative infinity. Okay. Questions on that one? One more like this. Let's do the right one. What is our first term going to be in our standard form? What are we going to start with? Gorgeous. Yes, that negative 7x cubed goes in front. That has my biggest exponent. That is going to be our first term when we're putting this in standard form. What's going to come next? My 2 or my 2x? Which goes next?
2x.
The 2x. This piece goes next. And then our last piece is going to be that 2. That is a positive 2, so we add it on the end. So that puts us in standard form. That's what this does. Putting it in order from biggest to smallest exponent gets us in standard form, which means our first term is the one that's in charge. That's the one that tells us our degree and our leading coefficient. So what is the degree of this polynomial? And what's our leading coefficient? -7. So are we odd or even? It's odd. The degree tells us if it's odd or even. And is this positive or negative? Just drinking my coffee, so I'll write it afterwards. Negative. That lets us figure out our end behavior. So we know that I am way too close to the edge to start writing right there. And there we go. As x approaches positive infinity. So as we go further and further to the right, it's going to match up with our leading coefficient. So our y's are going to approach what? Yes, negative infinity. And as x approaches negative infinity, so as we go the other way, what's going to happen to our y's? Positive infinity. Good, because our odds always go in opposites. Okay? Questions on those two? I feel like we're pretty good with our equations right now. We're going to look at two pictures, which I entirely meant to print out and 100% forgot to. So just like give yourself a little sketch, and I will zoom in on the pictures right here. All right, so it's very much like the bell work, but what we're gonna do is we're gonna figure out how many roots it has, so bell work question. What do we know about our degree? What do we know about our leading coefficient? And we're gonna do that by looking at our end behavior here. So, first things first is how many zeros or roots does this have? How many? 3. 1, 2, 3. It's those x-intercepts. What do we think about our degree? Is it going to be odd or is it going to be even?
Odd.
Why odd? Because the arrows go in opposite directions. So we know because they point in different directions that it's odd. What do we know about our leading coefficient? Is it going to be positive or is it going to be negative? What do you think? Remember, our right arrow always matches the sign. It's going to be positive. Because our right arrow points up, our leading coefficient is going to be positive. Okay. We're gonna leave it, I think at that point we'll go into more detail about specific numbers as we get there. But yeah, so if we have opposite arrows, that means the degree is gonna be odd. Our leading coefficient is gonna match that right arrow, so it'll be positive. So let's look at the left-hand one. That's pretty much what we're looking at on these. Double checking the homework and making sure that's all. Yes. Just making sure I cover our bases. I don't want to leave you guys out. Let's look at the right-hand one, and then we'll have time to work for the rest of the period. All right. How many zeros does this one have? Just x-intercepts. So one, ooh, wrong color here. 1, 2, 3, 4. So we have 4 zeros, roots, solutions, x-intercepts. That's what those are. Is this going to be even or odd? Even. How do we know it's even? They match. They're both pointing the same direction. Because they match, we know it's even. Just like if it's even, we know it matches. They match, we know they're even. Works both ways. So is our leading coefficient going to be positive or negative? Positive. How do we know? The right, they both go up for sure, clearly positive, but the right arrow is the one that tells us that. The right arrow is the one that tells us it's going up versus down. So if the right arrow went down, then our leading coefficient would be negative. Okay? So it's not a super amount of detail on the graphs, but just one of those things. Questions on this one? Of you two? Because that's all I got. That is not true. That is not true. I don't think. I will double check, but I'm pretty sure that's not true. That's really old data, November 16. Holy cow. Definitely not testing in November. I believe it's January 28th, but I will double check. But that is from last year when we did this chapter. That means I imported from the wrong year. Okay, so you guys have 10 minutes till the end of the period, about 7 minutes until announcements start. You can now do the entirety of that worksheet from yesterday. The whole back is cleared to ready to go. So let me know if you have questions. I'm happy to help. I'm going to make sure all of our attendance stuff got updated. But yeah, work on stuff. That first homework is due tomorrow. If you get it done early, you are always welcome to put it in the bucket early. But you guys have about 10 minutes where you can work on it. Ask questions. Let me know how I can help. I'm totally game to help.